So can you, when we speak of high rises, I think the foundation system is one vital aspect. So can you walk us through the key considerations for the foundation system of high rises? And while, when we think of high rises in coastal regions, what challenges do you see in coastal regions?
Yeah, well, I think for Dubai, we don't have bedrock here. So Dubai, it is a gypsum, it's primarily sand and it's a gypsum composition. Unlike New York, where all the super tall towers, those super tall towers are connected to bedrock. So for ours, we had to use the Brett system for the capacity since it's going up so high and the slenderness ratio is so tight that we had to use a Brett system in order to achieve the forces or to accommodate the forces. And then as you go up, obviously, or go deep, let's just say, we also had to get the force bulb. We had to do a survey of the surrounding buildings and the surrounding foundation systems to make sure the force bulb from our foundations did not disrupt or interact with the surrounding buildings. Also, there's a global settling, which is limited by DM municipality to 5 centimeters. So we have to respect, there's some criteria. Right now, the site is censored. And any kind of movement that exceeds 2 millimeters is automatically tracked to understand what's happening. So for us, the geotechnical aspect, I mean, again, this is a mega tall tower, so it's not necessarily applicable to different towers. But for us, the forces were of such such a degree that geotechnical became a very big issue. And then also just to be able to support that that weight on such a small footprint became very important. And then it was, the Brett system that was the Brett system that enabled us to be able to handle those capacities. We actually worked a lot with who did the Bretts is Solitanchi Bashe. They're the recognized leaders in the world for doing Brett systems. They do Brett systems. Hong Kong has similar issues in terms of having very tight sites, and they use a lot of Bretts there. Mexico City uses Brett systems due to their seismic and being on a lake bed. And Solitanchi Bashe does a lot of these projects, so they're the experts. And so we've worked with them on the first project, and then on the second project, we've worked with Solitanchi.
We speak about high rises. The most important thing is about the wind and the structural stability of the building. So when we speak about structural stability and load management, there are two important aspects of high-rise construction. So what are the key considerations for managing wind loads and wind-inducing motion while designing high-rises?
As you rightly said, for a city like Mumbai, often the wind and the lateral system is the governing factor for the entire design. But that is the way a structural engineer thinks about a high-rise. The way an architect thinks about a high-rise is the form of the building. If it's a residential building, what are the best views? Because often your plot is on an ocean or it's in front of a park. And in doing so, you may end up with a shape and form of a building which may not be the most structurally the best and may not be something which is behaving in the most wind friendly way. So once the parameters of the design are set in terms of view, location and all of that, it's only subsequent to that we start looking to shape and form the building to behave better with the wind. Unless it's an office building or a hotel where you can shape the building to be more in tune with the wind and the other factors that you mentioned.
Great, thank you. Matt or architect Nilesh, anybody wants to add anything to this?
I agree. I mean, the wind is the governing thing. The wind was the governing thing for the Burj Azizi. And we went through several different massing studies. And it does control everything in terms of the stability, in terms of the drift. And so for us, it greatly affected the massing. We added notches into the building to be able to not have hard corners where we had vortex shedding that started making the building move. We had crosswind movement, and by cutting out the corners, we were able to confuse the wind, so we didn't get like a laminar flow and get areas of high pressure and low pressure. So they were equally distributed. But yeah, the wind, dealing with the wind, yeah, it is all pretty much governed by lateral stability and the wind. So it's a very key aspect to address on high-rise house. Also for comfort, a lot of the buildings have balconies. Also for pedestrian comfort becomes a very big issue for us. We have readings of 6 kPa on our facade as we go up to the very top. We do have some outdoor areas, but again, it's limited in terms of the high wind speeds as you get higher in the atmosphere, let's say.
Thank you. So when we speak about construction waste is obviously a very important factor to be considered. So today's world is, we are moving towards sustainability, and it is very important as well. So what are your methods, or probably what methods would you suggest for handling construction waste in a diligent manner?
To handle construction waste, we're talking about when we are building high rises. Actually, the quantity of construction waste is very limited to from the new product. It's quite limited because it's been very well organized nowadays. From how we imply materials, how do we move the materials? What is actually needs to be handled is the excavated waste which is coming out of the earth, which we are replacing heavily, and those spaces needs to be discharged in a right format so that the dumping areas are well formed for absorbing the extra material coming out from one side to another side. Now coming to the primary part of the other construction waste while we are building upwards is the ones which how many number of materials do we reduce on? As external material, which is the primary material which is creating a lot of wastage around, what is the number of materials we reduce on? Secondly, how do you reduce the weight of the building so that again there is less material usage? So those are the factors for construction waste management overall which we need to work. Rest, actually most of the construction waste management has been very well organized already in the industry.
Yes. Carl or Matt, anyone wants to add anything on this?
Yes, ma'am, I will add into it.
Yes.
Nowadays, the government is more focusing on this, the demolition and construction waste. Many these units, construction means this crusher units, they have installed their crusher plants at many places, and they are manufacturing this sand and coarse aggregate from the construction demolition waste, and they are supplying this to industries as per their requirement. But as per the standard, actually, the IS code is allow only to use up to M25 grade and only the 20% replacement of the natural aggregates. So, because this construction demolition waste having higher water absorption and this less specific gravity, and that's why there is a restriction in the grade of the concrete. So, mostly it is using for the PCC concrete or the non-structural members. So that's many like Hyderabad, Mumbai, and many places. The construction demolish, this.
Okay, sir. Thanks for your insights on that. So I move to my next question to Matthew Fanot. So when we speak about high rises, data collection and management, could play a very crucial role in the structural health monitoring of these high rises. So how is technology accelerating this, or facilitating this accurate management of data collection and health statistics of the building?
Yeah, so that's a good question, because actually this project is so large, we're actually dealing now with a data consultant in terms of just the vast amounts of data and how we manage that data for this project. So it comes from anything from the structural calculations that have different, very many. We have in-house structure, we have in-house MEP, we have a lot of services in-house. So the ability to manage all this data, we worked with RWDI, as I mentioned, and the climatic data that they collect for the wind and the movement of the building and the models that are created. It's for us has become a new era, because it comes down to also the capacity of our computers, the speed of our computers, in order how to actually navigate the data. We have the data, but able to navigate it is quite cumbersome. And everyone needs different types of data, right? When we go to the Dubai municipality, they need to see extracted data that they're looking at. When we go to work with RWDI, we have to extract data. We have to extract the dynamic properties from the structural system. in order for them to win their wind tunnel studies. So, and then obviously the DM, not only the DM structure, but the DM, the planning needs to run all the GFA calculations and everything related to area habitation calculations, which obviously, changes somewhat with the developer. So it is key. There's all different types of data. There's actually the physical data. It was interesting. We're working a lot. Some of the people on our team actually worked on the Burj Khalifa, and they're talking about for the building movement, you're going to have these big cable trays in order to put all the sensors in. Keep in mind for building movement, to monitor building movement. Keep in mind the Burj Khalifa was done in early 2000. Now 2025, we work with the RWDI, and building movement can be done through Wi-Fi. You don't need any kind of hard cabling. You can bring in basically a laptop for any kind of motion detection to monitor the building. But also even just for the concrete, there's been a lot of discussion about concrete, different mixes and everything. And obviously this is an ongoing thing that we need to monitor on the site. We have a lot of different mixes for the concrete. And that, also contributes to or has an impact on creep and shrinkage that we need to monitor and track. So yeah, I think when you start working in such a large realm on some of these, mega, it's not just mega skyscrapers, all these skyscrapers that we're talking about, the amount of data that now we're collecting to be able to monitor these and make sure that they're working within the criteria that's been set forth. There's just more and more data that I think now is really putting a burden, a demand on how you sort that data and access that data.
Okay. Carl or Nilesh, anyone wants to add anything
So,
with respect to the Indian context? Yeah, please.
Yeah, for respect to Indian context, it's like, so nowadays all your new age buildings are being made by BIM softwares like Revit. So that is the primary starting point of data from the architect's office. And later from the structural guys, a lot of data is also coming embedded inside from the structural, from the MEP. And everything now, what we are doing is also very well automized for data collection from the system, from the power source management to the water management of the things, waste management of a project. Everything is well collected. There are few projects in India already where IBM Maxo is already implemented for managing the whole project post delivery, from their maintenance cycles to their equipments, which are already fitted with BMS chips inside. So data management, when it comes to post, is already very well started to become organized in India. So it's like CDE systems is also already implemented in some buildings in India, especially ones which are coming up in Delhi now, to manage the impact of earthquake, which is coming because they have higher frequency of earthquake, and to understand whether any faults are coming over on the facades of these buildings, and to take precautionary care if after every earthquake movement is happened around in that space. So I suppose, and then those are the primary ones which I can come out of the bag, which are the new ones which are around, and rest I think so is there. Thanks.
Okay, thank you. My
I have
question. Yeah.
one thing to add to that. An
Sure.
interesting thing that just happened to us, and we just met this week. My municipality requires to upload BIM models for a high rise.
Right.
And we've been operating like this for even back in 2013. I think this requirement came back in 2013 in terms of submitting BIM models. But now they have just implemented their first step in having digital twins. And so now during the midpoint in our development, it's past midpoint, they've introduced new criteria not criteria, but inputs and parameters that we now need to track in the Revit models and the structural models. So there's a lot of parameters that we have the parameters. It's not like we're working without the parameters, but the very specific formatting and the way they want that information input into the Revit model is very specific. And anyway, it caused kind of a stir for us because there's a lot of work involved with it. It's a lot of data that we need to input. And so it's just kind of interesting the way that the kind of the computational field is evolving and how municipalities are evolving in terms of how they want to collect data, what they want to be able to use for data. Even for insurance companies, what kind of data collection they want impacts how the information that you put into the Revit model. So it's an ever evolving situation. But anyway, it was just an interesting thing that happened this week for us.
So, yeah, thank you for that. My question to Varun, I hope Varun is there. Okay.
Yeah, no problem.
Yeah, okay. So you spoke about RMC. When we speak about RMC, when we speak about high rises, basically, so maintenance is a crucial aspect for the longevity of high rises because we can't keep building them again and again. So how does using RMC reduce the frequency of repairs when it comes to high rise buildings?
Yeah, so you rightly mentioned the longevity of the structure is the key criteria here. So RMC plays a major role in that now, and it has become the need of the hour also now, because with RERA coming in place and all. So it's not about one-time construction cost, but as a buyer, as a builder, everyone is focusing more on the total cost of the ownership for that particular residence or whatever. So in case of RMC, since when RMC is manufactured, so what we are using is a highly computerized and automated batching plants, which help in ensuring the best and consistent quality of the finished good. So it's not only the finished good what we are delivering at Prism, we ensure the incoming materials, whatever the raw materials are used for manufacturing of ready mix concrete. So all those incoming inbound materials are being monitored very regularly and with very stringent rules. So that, and we are following methodologies like QSUM and also to ensure that the incoming material is consistent. As a result, the outgoing material, the outcome of the finished good is also consistent. And then at the site, what becomes more important, how the people are placing that concrete. So at Prism, we ensure the deliveries and the placement of the concrete also by training the staff, the skilled and unskilled labor at the sites. By training them, we ensure that the placement of concrete is they are using the best construction practices, so there are less of surface cracks and the other things like honeycombing and all those things are minimized. So through RMC, it's not only one-time construction cost, but the maintenance reduces, and as a result, the overall total cost of ownership also gets optimized.
Oh.
Thank you.
So the next question is on retrofitting. So I think like it's actually the continuation of this question, like, you know, when we speak of such cost intensive things like high rises, you can't have the building built again and again. So what are the challenges when it comes to retrofitting high rises and how are they to be mitigated? I could have the global view also. I could also want the I mean, from the Indian context. This is to anybody, Carl or Matthew or Nilesh can pick it up.
I can speak to that a little bit. I mean, in terms, we do have a program with Azizi. Our building is going to take 5 years to construct. We will not be surprised if things change over the 5 years for those uses. So we look at it in terms of building in adaptability. So primarily we look at creating the infrastructure. In a certain sense, we really do look at this as a vertical city. So, and then for us, I mean, in a high rise, and I think it's true for everyone here, it really comes down to your core size, your exiting capacity. And then in terms of anticipating what that use might be, whether it's an assembly use, in terms of cooling loads, there's smoke evacuation, makeup air that needs to be provided. But we look at it very carefully. We look at it in terms of different uses. Obviously, not everything can be assembly use. That's going to be your highest occupant load. So we look at the potential of program pieces to change. And if we have I mean, we're divided up. We also look at it in terms of separate skyscrapers. We have 8 MEP plant floors. Basically, we have 25 stories between MEP plant floors. So we can take a zone and look at that and say, if it switches to a different use, do we have mechanical backup? Do we have the water? Do we have the air that could accommodate a different use within reason? So it is an important question because these things will change. These skyscrapers, when they're built, it's a tremendous effort, tremendous costs. and they need to be adaptable. And so I think it's a very important question, especially over the span of hundreds, 150 years, as long as these skyscrapers, the longevity of these skyscrapers is a very extremely important question.
Thank you, Matt. And I would like to have your views
Yeah,
on this.
to add to
please.
this, there are about, I think so multiple reasons to consider while retrofitting. Structural being one of the major reasons, you can say structural and the internal design of the structure, whether it is sustained to other types of retrofitting which has been added to it. Mechanical, electrical, already Matthew has spoken over that, which will become part of the requirement of retrofit, and the viability of retrofitting it, which is a very big challenge because as you go very high and taller, as you go taller and taller, the whole value of retrofitting the facade is a very expensive process. Now, this is something which needs to be considered at the time of design so that retrofitting as a facade can be reduced as much as possible. Again, coming further, as you say, retrofitting or reuse of the space into some other type of spaces, government compliances will start changing in time and also for different type of use. So the government compliances, so design does a designer think over that whole process, that 150 years? What shall be the future government compliances which will affect the building, and how do we take care of its retrofitting? The smaller part is nuisance of retrofitting to the user which is already into that space and to the surrounding environment around. So that is another retrofitting issue which we need to work on, and creating how do we create more sustainable buildings so that it can diversify from multiple use. It can at least have 2-3 types of use in its life cycle at least. So, and I think so these are the major topics of retrofitting which needs to be thought over. Yeah.
Okay, thank you for that. So I have another question related to fire safety in high-rise buildings, because primarily when we talk about residential buildings, the safety of residents, it plays a major role. And what would be the key challenges while designing for smoke control in high rises? Prevention is one thing, and prevention is what we look at. But just in case there is an incident of fire, how do you think the design should support easy evacuation or safety of people? This is for both of you. Anybody can pick it up.
Yeah. So now when we're talking about fire safety, one thing we need to clearly understand that fire due to accidents naturally existing inside a structure for some reason, that is one. And there is a different type which is like a more like an attack situation which happens once in a blue moon, but whatever. So the fire safety part, I think so we are well taken care by all your forced ventilation systems. How do you create spaces for securing human into a wet zone or a zone which is well kept away from the fire movement path? And how do you direct the fire into a particular method so that it keeps the movement paths more free? So I think so those laws are already well in place. Further up is most of our things which we take up as material are fire rated for multiple number of hours. We need to increase those conditions. I think so that is all about fire which I can contribute to.
Matthew, would you be able to add anything?
Yeah, I think, for us, Dubai municipality is very strict in terms of fire. So our exit stairs need to be encased in concrete, not in block wall. They have to be fully secured within concrete. We have firemen's lobbies that are dedicated, secured within concrete. There's no other services that can be there's no other services that run through these firemen lift elevator lobbies. It serves the whole building. It serves from the basement all the way up to the 140th floor. So in terms of evacuation, the very secure evacuations, you are in a separate building. Once you enter and exit, you are completely separated in concrete, encased concrete from the surrounding building. And then in addition to that, you have smoke evacuation on all your public corridors. Make up air, smoke evac. You've got pressurized stairs. You have floors of refuge, areas of refuge. In some cases, you can use the elevators for some buildings and towers in Dubai, you can use the elevators as a means of evacuation. For Burj Azizi, we're not doing that. We're using the stairs. They all have trades, they all have different kind of benefits and disadvantages. But I think in terms, I think one thing, and it's very similar to New York, how New York is required now, or the US, well, New York is all state by state, how cores are now required to be encased in concrete, 2-hour fire rated walls. So I think the more kind of, unfortunately, with the disasters that have happened in the past, they affect the codes, and the codes get more stringent, but it's all for the better. The buildings are more robust, they're more durable, and they're better able to withstand, these catastrophic events. I think you might have read in the paper a while back, there were buildings in Dubai that did have the skin catching on fire. And a lot of that is from contractors actually substituting materials and actually using materials, aluminum composite panels that have combustible interior core. No, in Dubai, the code requirements are you cannot have any kind of combustible cladding. It is needs to be non-combustible. Ours is either glass or it is solid plate aluminum. There are no kind of core buildups. So it comes down to the materials and then how you protect the people and how you protect the evacuation pathways.
Okay, thank you for that. I will have a last couple of questions out here. So one important question that I wanted to ask is architects and somebody who's constantly with high rises. Do you think the design of a high rise is offering architectural flexibility or the design flexibility as much as it is required? Because there are a lot of factors to be considered when we go in for the design of high rises. So you could share your thoughts.
Could you repeat that, please?
Like when we consider the consideration of, when we construction of high rises, we have, do you think that architects are getting the complete flexibility, or, the design is able to reflect the architectural creativity? Or because there are too many things to be considered when we go vertically high?
Yeah, I think it's a different thing that, we need to encounter now that we doesn't necessarily have. And I think it's a new phenomenon, right, that the world is facing. India, Asia, Dubai, these high rises. And it's the way actually we need to grow now. I was reading something from the UN where over the next 10 years, the equivalent of the country of Switzerland is going to have to be built in terms of built up area for people coming into the cities. So I would say it is a new paradigm. For sure, it's a new paradigm. And I think there is flexibility. I think you've seen in this presentation by the green buildings that were shown and by the different buildings that were shown, I believe there's a lot of flexibility. I think the design exercise is different now. When you go high rise, there are certain constraints. I know one thing that's really one thing that I didn't really even touch on is with the mixed use building in terms of destination points. How do you get people immediately to where they want to go, not take a lot of transfers, and try to make that trip as seamless as possible? It is a very big challenge, but that becomes the design study. And I think kind of design studies change into thinking about flexibility, logistics, adaptability. How do these things actually work, from loading to how people walk into the buildings, how they experience the grounds around the building, how do they get to their unit, what is their experience as they go from the front door of the building through the elevator lobbies up to their unit once they get out their unit. So I believe there's opens up a lot of opportunities, but they're opportunities that are a little bit different than maybe if we go back 20, 30 years ago in terms of conventional design approaches.
Architect Nilesh, I would like to have your thoughts as well.
I think so. He said it all. I don't see there is much more. So yes, high-rise building does change the thinking line of approach towards design. But when you're designing for any type of human, anyways, there are restrictions because each type, each sect has their own different requirement. You know, from a small house made in South India to a house made in North India, they have a different thinking, different requirements. So constraints have changed from time to time, and now it's becoming, in fact, more challenging and more data driven. Also, to understand how to design high rises in collaboration with multiple other consultants. So I think so the field has expanded heavily from just being an architecture field. I think so we are now moving heavily on the engineering side also, and its engineering is also a part of evolution of design. You know, so I think so engineering and design combined together is the future, which is going to just take over things. So yeah, rest Matthew has already covered it well.
Thank you, Nilesh. We have two interesting questions from the Q&A. So one question is to Nilesh now. Okay, so the question is, how is the impact of temperature change tackled in high rises, and how does it impact facade perform?
So my study is more towards India. So let me be specific around here slightly for that purpose.
Sure.
Yes, we are in India, we are a tropical climate, and in North, we have much more differential climate zones from very cold areas to hot areas. And so materials to use from the facade is what needs to be understood. As we go higher and higher, we require to use lighter and lighter material and more materials which are created in factories, so it can be easily installed, pulled up by cranes because humans cannot carry it anymore that tall. So the material research for India is like, how do you have insulation very well done, reflective materials on the surface of it? So do we use glass throughout, or do we use glass with furthermore technology so that we do not take in the heat directly from the southern side? Basically, you will have to create directional analysis of each sun path movement for each surface heat gain, heat load, what is coming to it, and design materials specific to heat loads from each side. You know, not go for a general solution of having all glass enveloped or a all single. So it's like the south has to be designed separately. The south, so different directions have the different requirement of heat load. So I think so insulating materials, multiple glass is the easiest material because the least maintained material is glass and aluminum as a surface material. Then you after that you have layers and layers of insulation, and then further the internal material comes in. So that is the part which I think so. And these all comes in ready-made panels, which can be produced in factories and retrofitted, can be fitted on site like a jigsaw puzzle.